Good morning to everyone signing on. As usual, we're going to give it about 3 minutes for folks to get set up. And until then, please feel free to say hello in the chat. If anyone has any questions, as always, please leave them in the Q&A section. And if you have any comments or something you want to bring up along the way, please do so in the chat. I will be monitoring both. Yes, good morning as well. Well, good morning, good afternoon, and good evening. I know a lot of you are in very different time zones. Okay, we're gonna wait about 2 more minutes and then we'll get started. Okay, so we still have a number of folks signing on. We'll get started at 8:03 a.m. my time, which is Eastern time. So about 1 more minute. Yes, so I think that's actually the first thing I'll bring up. We've gotten a lot of requests for extensions through the holidays. In order to request an extension, please go on Canvas and file a support ticket, and that way we just make sure that you have access to the modules beyond the due date. And yes, like you are welcome to request an extension. That's fine by me. You just have to, you just have to file a ticket in order for it to be processed. Hi, good morning. No, you haven't missed anything yet. We're about to get started. Okay, so welcome on board. I think at this point, like, first of all, congratulations for making it this far into the course. You've all made an incredible amount of progress pretty quickly, and I do want to acknowledge you for that. And at this point, I think since you've got a basic familiarity with the pandas library, some of the transformations that are possible, ways in which you can manipulate and interact with and make sense of data, like now I think is a good time to start talking about data visualizations. One second. Okay, so at this point, I think it's about time to start talking about how to actually best communicate the results of whatever information you're beginning to analyze and draw some conclusions about. So the last time that we were here, we took some averages, percentages, looked at little bits of aggregate information, and we got a sense as to some things that were going on. But if you're presenting results, especially to stakeholders, starting to answer bigger data science questions, summary tables are not usually the best way to do it. In fact, just most of your audience that you communicate any information to will generally prefer to process it in as visual a manner as possible, unless they are requesting tables. Just actual graphs, charts, and pictures are generally considered to be much more effective at communicating trends, group differences, highlighting the importance of information. So data visualization is ultimately, I would say, one of the most central skills to data science if you're working with any type of external stakeholder. And we're going to go through two of the most popular libraries available within Python, which is Matplotlib and Seaborn. I'm personally a fan of Seaborn, and I use it a little bit more in my work. There are also a number of other options that you can take a look at when you would like as you're practicing your data science skills. Like Plotly is a good lab to take a look at. Bokeh is a good library to take a look at. And I believe that there are DataCamp modules available on both of these. So if you are interested in results communication in data science, this is definitely, those are definitely libraries to look at. But Matplotlib and Seaborn definitely make the foundation of most of what's available to you within Python. So let's get visualizing. The first thing I want to actually point out here, so most of the plots that you're going to use within Matplotlib are in matplotlib.pyplot. Like Matplotlib has a couple of other sub libraries where you can manipulate colors, I think dates and times, a couple of other things, but most of the actual like plot choices like bar graphs, histograms, scatter plots, etc., are going to be available to you under matplotlib.pyplot, and that's what's usually imported as PLT. When you're working in a Jupyter Notebook, another thing you'll generally want to do is also use this command matplotlib inline, which just allows the plots to be displayed in a bit more clean of a way, because otherwise you're going to get a line of output that like you'll just get like a brackets and some output. And if you're looking to present the entirety of a Jupyter Notebook to somebody, it's just a little bit less presentable. So keeping this in here just keeps it cleaner. So let's go ahead and just import that. And Matplotlib in particular is pretty flexible in terms of what you can visualize. If you started working on this week's DataCamp module, you've probably noticed a lot of the examples in Matplotlib use lists, use like NumPy arrays. It's pretty flexible depending on what it is you're actually trying to visualize. And we'll talk a little bit more about what that looks like. So let's actually start by importing this week's data set. And I think this may actually answer a question from last week's webinar around how do you import data like from the web, from an API, as well as different formats. You'll notice what I'm doing here, as opposed to read CSV, is pd.read JSON. So JSON is like, it's a JavaScript file, so it's usually in Python that's interpreted as a dictionary, and sometimes it's dictionaries within dictionaries within dictionaries. pd.read JSON fairly successfully will parse that information and then turn it into a standard pandas data frame. Sometimes it's not perfect, I will tell you that, but for the purposes of this webinar and the data that I'm pulling here, it actually works very well. So the data that we're pulling is actually from the NYC Open Data Portal, which if you're looking for interesting data sets, I strongly recommend you take a look at. One of DataCamp's instructors, Dave Robinson, who teaches some of the R courses, actually uses that data a lot in his own weekly publication called Tidy Tuesdays, where he teaches you about how to use R in the tidyverse. So there are a lot of interesting things there. There's stuff about like the health department, there's stuff about the environment, like in the environment in New York City. There's a census of squirrels. So if you're interested, there's a lot of just very silly and entertaining and fascinating things about processes in operating one of the biggest cities in the world. So strongly recommend you check this out. So let's actually go ahead and import the tree census. And you'll notice that what I did here already is drop a lot of the columns because it is long, like this is a very long data set. I'm gonna go ahead and import it. Takes about a second. It's not the biggest data set in the world. And then you'll notice that what's actually left here is like the address of each tree, or I guess the address of whatever building it's in front of, the borough name, the district, when the record was created, and a number of other things like this, little bits and pieces, like what the health of the tree is, the latitude, longitude, species, whether or not it's alive, and just some other stuff. Like this was a pretty big endeavor that I believe occurred in New York City back in maybe like 2011, 2012. I don't actually remember when this was, or oh, there, 2015. There's your answer. And this data set, I think, is actually pretty good for taking a look at some examples of how we can visualize things. So we answered a number of questions, like we said, just by grouping information using pivoting, using group by, using pivot tables, cleaning up whatever data we needed to draw those conclusions, aggregating it in different ways. We can then actually just use matplotlib to generate graphs using the df.plot method. And I would actually read about this in the pandas documentation because this is a panda specific method of plotting things. Excuse me. Basically, this is the syntax for this is a little different than maybe some of the examples you've seen in the DataCamp module, which does plt.plot, and that's specific to matplotlib. df.plot allows you to actually just plot directly from the data frame. Ultimately, the reason I'm showing you this is to say that there are a number of different ways that you can produce plots within Python. And there are a number of arguments that you can specify when you are presenting your plots. And this specifically, like this section specifically is about making your plots look nice. And we'll show some examples later on. Matplotlib inline suppresses the text output that generally comes with producing a plot. If you put a semicolon at the end of creating your plot, which we do down here, that suppresses the last, they're like two pieces of text output. Matplotlib inline suppresses most of it, the semicolon suppresses the rest. This command plt.rcparams figure size allows you to specify the width and the height of your plot, which is specifically pretty important when you're using a Jupyter notebook because these are designed to be presentation friendly. And then you generally want the plot to be big enough for people to see, and sometimes the default size is actually pretty small. So I'm going to comment this out just to show you what this looks like. What we're actually going to do, first of all, is use, we're going to use the df.plot method and create a bar graph. The way that this works is we actually first need to summarize the information in the way that we want to present it. And that's fairly unique to a bar graph within Python. If you're using either df.plot or plt.plot with matplotlib directly, you do have to pre-aggregate your data before presenting it. So you'll notice that what I'm doing here is I'm actually just answering the question of how many trees are there in each borough? And the first thing that I do is this. So I take the trees data frame, I group it by the borough name, I count the number of records, which is the number of trees. I reset the index, which allows me to then use these as labels as opposed to it just being the index. And then I start plotting things. If I wanted to, I could save all of this as like trees per borough or something like that. That's entirely up to you. since this is a simple aggregation, I didn't do so, but I can do and then do something like this, trees per borough dot plot, and then moving over to the left. But that's truly just a matter of preference. And I'm going to go through the different arguments that are available here just to show you what this looks like. You have to specify your X, which is the grouping variable. You have to specify your Y, which in this case is going to be called tree ID. I'll show you because I actually did just know this ahead of time. So let's just take a look at what this looks like. So now I got a count for every single column, and like it's identical for each because it just counted the rows in every column. So in this case, I just grabbed tree ID, which is any one of them. And then here, what I'm specifying is kind equals bar. And with the pandas data frame.plot method, I actually have a number of different choices. In this case, I choose a bar graph because I want to just show the count of trees per borough. I want the bars to be purple. There are a number of different options with color. I think with generally like any of the standard colors, you can like there are a number of colors you can specify by word. You can also, I believe, specify HTML and hex codes. If you're familiar with any of those. I don't need a legend because I'm only showing 2 pieces of information. Like this may not actually, sometimes a legend's necessary. Like if maybe I had 3 pieces of information that want to identify different colors. And then I also want a title. So I'm going to create this. And you'll notice that the default plot here is pretty small. Which is actually why I commented this out to show you when you're working on a Jupyter notebook specifically, or even in a local environment, your plots will have a default size that are often smaller than you want them to be, which is usually why you'll want to specify the parameters in terms of how wide and how high, like this is width, this is height. And if you actually recreate it, it's just a lot more easy to read. And then let's say maybe you want to export this and put it into a PowerPoint. Maybe you want it to be part of a larger Jupyter notebook that you're presenting to more of a technical audience. But ultimately you have your options, and either way, it's just more easily presentable like this. Does anyone have any questions so far? I'm going to give it like 30 seconds if anyone's typing anything out. Okay. I'm going to move forward, but if we do have questions, I'll take a minute to, let me see. Can you import data from an Excel file? Yeah. Pandas also has a pandas read underscore Excel. There's a really good course on there's a really good course on DataCamp called I believe it's called Streamlined Data Ingestion with Pandas that goes through a ton of the different options to effectively import your data. Yeah, but it's pd.read Excel. Read underscore Excel. That is possible. There are a couple of different arguments you have to specify, like which sheet number you're bringing things in from, if there's any formatting you need to skip. But yes, you absolutely can. It's called, I'm going to type it in, it's called Streamlined Data Ingestion with Pandas. There you go. I think you can, yes, I think you can also read in XML. Like most standard file formats, you can read it in CSV, TSV, XML, JSON. Like Pandas has a lot of different options for importing. And the goal of all of those imports is to result in a data frame that's of this shape. And okay, so if you want to hide the plot using code, um, general like if you don't want it to show in the output, like you can hide a cell. Let me see. So if you click this blue line here, you can just hide the cell. You can hide the output if you want to. That's probably the easiest way to do it, is to just click that and hide the cell. And then if you only just want to show the code, if you want people to see the code, but you don't want to run it, you can also comment it out using like hashes. That's probably the easiest answer to your question about how to hide your plots using code. And I also just want to quickly show you what it looks like without the semicolon. You basically just get this little piece telling you what the axis parameters are, and it just looks a little bit cleaner without it. It's mainly just about presentation. And the next thing I actually wanted to show you, which is pretty useful in a good presentation style. Okay. I'm not sure, actually. I think that's a really good question. Someone was asking if you can hide a plot in a specific time frame or something like that. Maybe. I think that's more of a question if you have a live dashboard that's running. Say like if you created a dashboard in Plotly and you only want it to refresh, I don't know, every 24 or 48 hours with new information, that's probably something you would actually create in the dashboard itself, as opposed to tying to an individual plot on a static file. Because this, for example, the Jupyter Notebook, if you are presenting it to somebody, more likely than not, you're going to be exporting it as a PDF or an HTML file. Alrighty, so let's actually take a look at something about subplots. So a lot of times you'll want to present multiple plots next to each other in a grid, depending on the information. And the easiest way to do that is through matplotlib's subplot command. So what we're going to do here is actually take an aggregate of a couple of different things. So we want to count the number of trees. And we also want to take the mean of the tree dBH, which was like the diameter, and then just save that as a data frame in and of itself. Yeah, so matplotlib inline is a JupyterLab command, and it mainly just says, it's mainly just a formatting for all standard plots. So I would keep that in regardless. Especially since like when you're creating plots and visualizing information, more often than not, you'll probably use a combination of different tools. So I'm using df.plot here. What I'm actually going to do in the next command is, or in the next section here, is actually directly from matplotlib. So like for the interest of presenting your information to different stakeholders, you will very often find yourself using a combination of matplotlib, Seaborn, and Pandas plot availabilities. So it's always just good to keep it at the top, the matplotlib inline command. And so the next thing we're actually going to do with the subplots is we're going to specify a few parameters. So the first thing you would specify is the number of plots you want in each row and each column. In this case, that's row column. The next thing you can actually specify is the combined width and height of the plots that you want, which, as you'll notice, was pretty similar to above when we specified the figure size. And then the next thing that's also worth keeping an eye on is the axis shared. And you have a share Y and a share X parameter that by default is true. So you actually, and this is only relevant. So share Y is if you have multiple graphs per row, because here's your Y axis. If you have, say, like a 2x2 and you have a grid of 4 plots like this, you would also want to specify whether or not they're sharing the X axis. So in this case, they actually are sharing the X axis, but it's not relevant because we only have one row of plots. So what we're doing here is it's actually height. So this is the tree height column. So what we're doing in this case, we've specified that we want 1 row and 2 columns. And what that then gives us is 2 objects, the figure and then the axis. So on each axis, which then has basically like a coordinate system. So as you'll remember, Python is 0 index. So in essence, what this means is at axis position 0, which is the first axis, give me a bar graph with all of this. So this is basically PLT dot bar with the trees group burrow name and then the count, which then, just like the plot that we have above, like this is identical information, this gives us a count of the trees per burrow. And then what this says here is on the next axis point, which is 1, so that's basically the second position, give me a second bar graph with the mean, which then tells you the mean height of the trees. And then generally you want to give them titles. You can also do subtitles, but subtitle basically means like the super title. So the overall title for all of your plots, which in this case is just number of trees and tree height by burrow. If you have maybe, let's say, more plots than what I have here, you might want to have separate titles to be able to clearly differentiate the information. But right now, this is generally enough. And then we can run it. And there you go. So the next thing we can actually do is create a histogram, but I want to just make sure everybody's clear on subplots because this can be a bit confusing. And if I'm just giving it like 30 seconds if anybody's typing out any questions. Okay, we'll move on and okay, yeah, take your time to digest it. Please feel free to practice. There's a lot of information in this data set, and when I'm sending around this notebook, this is actually going to be easier to import because you're not downloading a data set in an Excel format, you're just pulling it in directly from the web. So this should be pretty easy for you to then play around with and then answer some questions that may interest you about the trees in New York City. The next thing we're going to cover is actually histograms, and this is particularly interesting. Well, the thing with a histogram is that it's basically a plot of raw continuous data. So in your data science career, you are very, very often going to be exploring the distribution of information. That's a very important first piece of a lot of analyses that you're going to be doing. And the easiest way to take a look at like what the shape of the distribution is by plotting a histogram, which basically just displays the shape of your data based on groups of values. So in essence, by default, pandas or matplotlib will set a number of bins, which is basically just a range of values. So let's say in this case, we have a number of thousand of records, like a couple thousand records in this data set of trees. The height, for example, may range from, in this case, 0 to 40. I guess this would be meters or maybe meters. I'm not sure what unit they're using. It might actually be feet. And then by default, the idea is in order to clearly display the graph, since this is continuous information, like these aren't necessarily just whole numbers. So this could be 10.5, it could be 21.1, and you don't want to just plot each data point individually. You group them together in a natural way based on maybe like sets of 10, sets of 5, and you can specify how many bins and then play around with that based on whatever actually helps you communicate the information that you want to communicate. So if I just run plt.hist of the tree height column, And you'll notice I didn't aggregate anything here. This is just the column from the original data set. I am going to get a histogram that has way fewer bins. And this is interesting to take a look at, but what I'm actually curious about now is just like if you see, like if you're taking a look at it here, there's not a lot of nuance. So I might actually want to then add more bins just to be able to make better sense of the information, which is why I did this. And again, like you can play around with that based on what actually helps you understand the distribution that you're taking a look at. But there is such a thing as too many bins. Like if you go up to like 50 at this point, like that doesn't tell you very much. It doesn't like it shows you where things drop off, but it doesn't tell you much about the shape of the overall curve. So I'm going to stick with 25. And the next thing I'm actually going to do is using subplots. I'm going to take a look at the distribution of a couple of other columns. I got a couple of questions I'm going to take a look at. Someone asked, can you import data from any other sector such as healthcare, oil, or gas using the information above? Yes. If you know of a data set that's available on a publicly available website. I do know, for example, that NYC Open Data, which is the source I use here, does have a number of data sets about heating and gas consumption around the city. So maybe that's a good place to start. There will be varying levels of difficulty to grab information from different websites. If you are just getting started and you want to and your goal right now is to become familiar with different data sets, find a place like Kaggle, data.world, or NYC Open Data that already has curated data sets for you to use. But yes, you can. And pretty much like if any of this, you can actually just find your own data set, import that, and then change this up to take a look at whatever information interests you. Yeah, data.world has a great set of data sets. Kaggle has a great set of data sets, as well as people hosting competitions and sharing code. NYC Open Data is regularly updated. So if you're curious about the processes of a large urban metropolis, that's probably a good place to go. So the next thing we're actually going to do here is, this is pretty similar to what we did above with the subplots. We're just adding a third subplot and taking a look at some of the information that's available in the data set. So we have the tree height, we have the diameter of the tree stump, and then we have the date that the record was created, so the date that the tree census was taken. And what this will do now is, I'm going to actually put this back. And there you go. So what you'll notice I did here was I made the plot a little bit wider. I added one more column and I have one more axis point. And just like I did earlier, basically this is the equivalent of plt.hist. So this is a matplotlib histogram. If I do share, oh yeah, let's do share y equals true. You're not going to see anything, because in essence now it says this axis is going to be identical for every single one of these graphs. So then these just shrink visually. Like if you're looking at the same type of information, maybe counts, for example, or averages on the same scale, you might want to share the axis, but this doesn't actually do us very much. It just makes the graphs a little bit more difficult to read. And you'll notice that, so the stump diameter column doesn't actually have very much useful information for us. I wonder, for example, it's possible that this simply wasn't recorded and some fill-in number was given, and we can actually probably confirm that by going up here. Stump diameter, yeah, it seems like there just wasn't anything recorded in this column for most of the records. Which happens, you know, many times your data just doesn't have useful information in it. It does truly depend. And Yeah, so basically this is not useful information. We can actually swap this out for a column that might be more interesting. Say, I don't know. Let's see, something that's numeric, maybe like this. That's the district. I think that's about it in terms of actual measurements that you might want to take an average of. So I will leave that be. Does anyone have any questions so far? Because right now this is just mainly just an example of some different histograms. And you'll notice we are going to cover distributions towards the end of this class if you're not familiar with them, but there are a number of different types of distributions, like statistical distributions, that are worth keeping an eye out for. And this is just an example of two skewed distributions in the opposite directions. So like this is a right skew because the tail is in the right. This is a left skew because the tail is on the left. Okay, data.world. So thank you for asking. Someone asked what were the three data, the options: data.world, NYC Open Data, and Kaggle. Kaggle's definitely your friend in terms of just data sets. Someone asked a great question. Can this be used for the purpose of project analysis, like a regression Pareto chart? Yeah, I think that's more than fine. I think that's actually going to be a little bit in terms of the next section that we're going to talk about with Seaborn, because Seaborn is actually Python's statistical library, and it is designed to visualize a number of different statistical tests. So like it is designed to be visualization for just statistical information. And we're going to cover this very basically. Because like there are many different options in terms of Seaborn, but for example, the Seaborn, you can fit a regression line, so like a trend line maybe to a correlation graph. You can fit like there are a number of different options within Seaborn just to visualize the results of statistical tests. So we're going to go ahead and actually import that now, as well as import a pretty common, you've probably seen this data set before, the IRIS data set, which is like it is one of the most commonly used data sets. It's an example I've seen for classification, for cluster analysis, for many other different tests, because it does demonstrate a lot of different machine learning methods pretty effectively. So if you haven't seen this before, I would say actually check out just work that people have done with this data set, because this is a great way to just learn a little bit about different machine learning methods. So let's import this here and then take a look at it. So this data set basically just has information about a number of different flower species or subspecies, because these are all irises. And then there's just the information about petals and sepals. So the length, the width for the sepals, and then the petals length and width. And then based on that, there you also have the class, which is just the type of iris that this is. And very easily, just based on these characteristics, you can tell what the different species of flower is. So let's actually just quickly take a look. I've imported Seaborn as SNS. This is the most usual alias that you'll see. And Seaborn, I would argue, is actually very intuitive, like much more intuitive than Matplotlib in terms of just being able to effectively visualize information. So I do strongly recommend you become familiar with this library. There's a great DataCamp model on it called, I think it's just called Introduction to Seaborn. So definitely check that out. And let's actually start by just creating a scatter plot of the length, the petals, the length and width of the petals. Okay. And you'll notice quickly that there's one distinct group over here and then one big lump over here of the data sets, but it looks like this is a pretty good example of just what like the visualization of a scatter plot looks like. And let's also now create a couple of subplots. So you can use Seaborn in conjunction with Matplotlib in a number of ways. So in this case, again, we're going to create two subplots with one row, two columns, and specify the figure size. And then just like before, you're actually just going to specify what you want to take the length and width, so your X and your Y. And then one of the arguments that a lot of seaborne plots have, not all of them, so definitely read your documentation. Like I would read up on just the documentation of what's available in each seaborne type of plot, but many of them allow you to have an argument called the axis. So AX equals whatever the name is here, and then the index point, which then tells Python where to place your seaborne plot in your matplotlib axis. And you'll notice I also added another argument called hue. So hue is basically the argument coloring different groups. You'll notice, for example, here, like we have these, like this looks like a distinct group. This looks like maybe it has another distinct group. But in essence, we know what class each flower belongs to. And then this allows us to just color each data point based on what the flower species is. So if we run this now, this basically, using the default matplotlib colors, you'll notice, like this is the default color scheme in matplotlib, which isn't always the most presentable. So that might actually be something you'd want to change in your own work if you're presenting it. Like they use very bright, like blues, greens, oranges. Maybe that doesn't work for you. But what you'll see here is based on the information about the petals. This is indeed one distinct species. There's a moderately clear line between these other two. So you can very clearly see just where the different flower species are based on the information about the petals. It's a little bit less clear based on sepals. There seems to be a mix here, like in terms of just length and width. These two classes tend to meld together a little bit, whereas the blue group is pretty distinct. That's the Setosas, I think it was. And ultimately you can achieve this exact same output that we've done here with 3 lines of code, just using matplotlib, but it is a little bit more presentable. How do you transfer charts into PowerPoint slides? Okay. Honestly, I usually just export them. If I am planning on putting this in, like you can export them as an image. That's really just the best way to do it. Like if I'm creating a plot in my local environment, I'll usually use like Anaconda or Spider, and then you can actually just right click and save the plot. Here, what I would probably do is save the Jupyter Notebook, open it, maybe open it as a PDF or an HTML file, or I would just screenshot the plots. Like that's truly the quickest way to do so. If you want to make something more presentable, there are a number of tools like Mode Analytics, which is a business intelligence tool where you can actually just present things in a report format for people to view. There are also tools like Tableau that'll help you with data visualization, but really just exporting or screenshotting as an image is probably your easiest way to do this and put it in a PowerPoint. But yeah, I'm going to go through this part just fairly quickly, like this part right here. So in essence, what you can do this exact same thing, but a little bit more complicated. And most of the actual complexity is in how you color the information on your plot. So Seaborn very easily allows you to use the hue as an argument, which then you can label and color the different pieces of information. With Matplotlib, the first thing you would actually need to do is generate a dictionary of colors to map to each species, which requires that you know what your categories are ahead of time, which you can figure that out. But it's only like, this is only really a reasonable approach if you don't have a ton of categories. So in this case, I've taken each one of the flower species, mapped it to a color of my choice. And these are colors that are available within the standard color scheme. So like dark red, dark green, purple. And then in essence, there's a dictionary of just key value pairs where each key is a flower, each value is a color. And then I can set the figure width here. this is just a different way of doing the same thing in terms of setting the width. So in essence, I get the plot parameters. I set up the first subplot, which is take a scatter plot of the petal length, the petal width, and then the color is iris class column dot apply this lambda function of x of colors x. And then I can set the title. It's a little bit more complicated. It's really entirely up to you what you want to use. I personally just prefer using Seaborn. I do find it a little bit easier. And I'm also of the opinion it has better options, as well as a really great library. Let me see. I'm just going to show you guys Seaborn. Like there's a really good library of example visualizations to give you some ideas as to how to present data. So like Seaborn allows you to create just really beautiful plots. And here are just some quick examples. And here, for example, you can fit a trend line, you can fit the shape of the distribution, you can create box plots. There are a lot of different things here, so I would just check this out. It's I'll put this in the chat. It's seaborn.pydata.com. Like there's a lot that's possible that we definitely cannot cover in an hour. Yeah, absolutely. And the last type of couple of plots that I would actually want to cover is just first of all a line plot. Like very simply, this is just like, let me just show you what this looks like. So I'm going to use Seaborn, like this is a Seaborn line plot. And this is just a way of visualizing time series information. And there's not a ton that's particularly useful here, but by default, basically what this does is it takes the time series data and then adds the like the margin of error to it. So in essence, what this might tell us if maybe the trees measured over time got bigger, which they didn't. They just seemed, there's just a little bit of variation from like month to month or week to week. Let me see, what could probably put here is the district. That might actually change over time. Yeah, it varies. Like it really doesn't matter. I think the idea is like this, like if you have time series data, line plot, then you want to see just trends over time. Line plot is definitely your plot of choice. And I think the last big plot that I actually want to go through is just visualizing correlation matrices. So we're going to cover this a little bit more in depth in, I believe, the last class. And in essence, like if you're not familiar with correlations, in essence, a correlation is just the strength of a linear relationship between two variables. So if you're taking a look at this, for example, you'll notice that while you can see groups here in terms of petal length and petal width, you'll also notice that this creates pretty much just a straight line. So in essence, there is a very strong relationship between the length of the petal and the width of the petal. And that's true in a lot of like that's usually like the first, like if you're looking at relationships between continuous data, correlations are often the first thing that you will be taking a look at. Where you want to see maybe like if there's some trend and if something goes up, does this other thing go up? Like height and weight tend to be correlated. Honestly, a lot of things are correlated. Maybe like test scores and number of hours that a person studied. Yeah, like this is pretty much like one of like your first steps in terms of examining statistical information is very often a correlation matrix. And the easiest way in which you can do that is actually using the like df.core method, which in essence, you take a data frame and then you just chain .core at the end of it. And then I would save it because then it's just easier to take a look at. But what this then does is it goes through all of your data, takes all of the continuous columns, anything that's basically a number that it can interpret as something you can take a correlation of, it will automatically do so. And then it'll skip everything else. So like on the curve, none, fair, it'll skip. Everything else that's a number, by default, it will take a correlation, which also then means that you're going to have some that don't necessarily make sense. Maybe a zip code isn't that useful in a correlation, but by default, this method will take it anyway. So then what you can see here is just a the correlation matrix of relationships. And is there anybody on here who's not familiar with correlations? And I'm happy to give like a quick 30-second explanation or a refresher. Then I'll make the 10-second refresher. Basically what this is, this is a number between -1 and 1 indicating the strength of the relationship. The closer that number is to either -1 or 1, the stronger the relationship. A number of 1 indicates that there's a strong positive relationship like this, which is as the length of the petal goes up, the width also tends to go up. If it's an inverse relationship, maybe so if it's closer to -1, that's an inverse relationship. So maybe if a different species of flower, it's like if longer petals also tend to have, like petals that have greater length, maybe have less width. That's a negative relationship. And then that's closer to -1. So depending on the size of your data, like correlations between maybe like 0.3, 0.4 are considered to be like weak to moderate. Correlations between like 0.5, 0.6 are considered to be moderate to strong. Anything beyond that is usually considered to be pretty strong. It does depend very much on the context though. And if you're looking at data and be in a controlled laboratory setting, you'd probably want, or like medical research, you'd probably want much stronger correlations. If you're studying human behavior, they'll generally be pretty weak because you're studying complex creatures who've been on the earth for X number of decades, and it's hard to predict any set of behaviors perfectly. But you'll also notice this is not the most user-friendly to be able to just interpret the information on its own. Like, you know, you can sort it, you can, I don't know, take a look at it in different ways, but one of the things that actually just helps you make sense of this information is by adding some color to it. And Seaborn has a heat map that allows you to just color a correlation matrix based on the strength. And one of the argument that I'm using here is called a color map, which is basically just a range of colors. So if you think of Excel's conditional formatting, or if you think of like a number scale where it goes from like green to yellow to red, that's basically what I'm doing here. In this case, I'm doing yellow to green to blue. And Seaborn, the Seaborn.py data website that I showed you will also include what all the different color maps are that are available. So basically what this did is this took a correlation matrix, like this took the numbers from the correlation matrix and then just added colors based on the strength and the direction of the relationship. So in this case, numbers that are pretty dark in this, like here, are stronger positive relationships. Numbers that are yellow are stronger negative relationships. And at the diagonal, it's perfectly dark because the diagonal is always 1. Because in essence, what this does is it correlates each, like the diagonal is it's a matrix, so everything on the diagonal is correlated to itself. So it's zip code to zip code will be correlated at 1. That's just how a correlation matrix is presented. And this is something that's probably going to be a little bit more useful later on. And there are a number of different ways in which you'd probably want to, like this is a good first step to think about presenting statistical information to less technical stakeholders. And I think just the last thing I'd like to focus on are some best practices. As far as data science goes, visualization at face value may seem like some of the easier stuff that you could do. But there's a lot of care involved in effectively and accurately presenting information to different stakeholders. So it's important to think about who your audience is. Like, what are they going to do and how are they going to present your charts? If, for example, like let's say the correlation matrix, it is very possible that your non-technical stakeholders are not familiar with the fact that familiar with how to interpret correlations, which correlation does not equal causation, which means you can say that these two things are related. That does not definitively prove anything, and that does not definitively say that one thing caused another. And that's often a thing that can be misinterpreted by people who have less technical knowledge or less statistical and research knowledge, basically. So it is very important to think about who your audience is and how will they present their charts. And I think a good heuristic or rule of thumb for creating charts, if you're using like all of these different options that are available, for example, with the Seaborn, maybe you're using something like Tableau, is to really think about just like as a rule of thumb, will it like how long does it take your audience to understand the information you're showing them in your chart compared to how long it takes you to explain it? A chart is supposed to make things easier. So one of the, like a good rule of thumb is if a person looks at your chart and it takes them longer to figure it out, like figure out what's going on than it does for you to explain what's going on, you can probably make it simpler. Like the goal of visualizations for the most part is ease of digesting information. And yeah, like keep things simple. And if you need some examples, Seaborn's gallery is really great for just a sense of what's possible. This level of complexity may not always be what you need, but it is something that's available to you in this library. The next thing to think about is just how many axes are using. So like if you have an X and a Y, theoretically you can also overlay like another axis and just compare different types of information, but keep your message as simple as possible. That's really just my recommendation. I work with non-technical stakeholders all the time. I think that's probably where I have the most experience, is communicating to people who don't have technical knowledge and need to make decisions based on whatever you tell them on a day-to-day basis. Keep things simple. And here are a couple of resources that I've included that I'm going to be sending around with the notebook from today's webinar. Is just Tableau has a visualization best practices white paper, which is very good. Tableau in general puts out just resources, trainings, and white papers on just creating good visualizations. There's also a website called the DataViz Catalog, which is actually a great resource of trying to match the type of information that you want to create, or the information you want to share. So like, do you want to compare things? Do you want to show proportions? Do you want to show relationships? And then it gives you like a recommended list of charts based on whatever it is you want to convey. So like here, then you can say patterns, and then you can take a look at like some of the different options for conveying patterns, as well as look at some best practices for how to use them. And most of these plots are easily available within Python. So I would definitely say this is a good resource to use. This is also a really good article called Learning from Our Errors in Data Visualization, just talking about some of those best practices and what could potentially go wrong when information is not presented well. Especially if you're working maybe like in a big company or some kind of large stakeholder. For example, I used to work in government. So the effective communication of information could lead to decisions made that impact the lives of thousands of people. It's pretty important to make sure that you actually create, like take the time to create effective ways of communicating information. And practice, get better, use some of these resources, definitely the way to do it. We have about 1 or 2 minutes left, so if anybody has any questions, I would say drop them, like feel free to drop your questions in Q&A now, and I will take a minute to answer them. We got one question already I'm going to go through. Someone asked, would you prefer a stacked bar chart versus creating separate bar charts? In your experience, what do audiences prefer? It entirely depends on what information you're trying to present, and usually depends on the number of categories. So stacked bar charts are usually very effective, or usually more effective if across your groups there isn't a huge difference. So like I think I'll give you an example. So here, for example, if I wanted to also then categorize them by like, I don't know, species, it would be a little bit more difficult to see the species here than it would here. So this is an average with much closer bars. I've used both stacked and non-stacked bar charts, but more often than not, just having separate bars is easier, especially if you have a lot of categories. Does anyone else have any additional questions? Okay, then I think, okay, someone's got one example of how to import data from an Excel file saved in a folder in a laptop. Yes, I think the best way I can do that is just send you some code on how to do that. Because I don't actually have any Excel files saved since I don't have Excel on this MacBook, so I can't quite demo that at the moment. But yes, I can get you an example of how to do that. All right, and I think other than that, that's it for this week. I know a number of folks, again, have requested some extensions on the material due to the holidays, and that's okay. Please file a ticket with support through Canvas. And other than that, for those of you who celebrate, have a wonderful holiday. We'll see you back after the break. Yeah, happy holidays to all the different holidays that folks are celebrating this time of year. And yeah, I'll see you back. Yeah, I think we have a bit of a break until January, so I'll see you then. See you in 2020, and happy New Year to everyone.